This lesson is going to look at simplifying radical expressions, but now we're going to add variables into the mix. You might look at this and think that we've just made it harder, but I honestly think that the piece with the variables is easier than simplifying with just the numbers. So when we work through, we're just going to work base by base by base. The different bases, we're going to do each piece separately. And then the way that it works with the variables, we've already talked about what to do with the numbers. But the way it works with the variables is very similar to when you did like basic remainder division in 4th or 5th grade. You always ask us to go back to 4th or 5th grade math. So here's your moment. We're back to that. So here's what it would look like. Let's look at a very simple example up here at the top. Let's say that I wanted to do the 3rd root of n to the 7th. Well, as we've talked about in previous lessons, if I did the cube root of n to the 3rd, those would just become n. So this is sort of the long way to think about this. Then I'm going to show you the simple way to do it. What we're going to do is take 7 and divide it up into groups of 3. So I could say the cube root of n cubed times another cubed root of n cubed. And then if I look at what I've got here, 3 plus 3 is 6. So that means I need just one more. So the cube root of n to the 1st. So why did we do that? This is n. This is n. And then we have this cubed root of n left over. Now if I multiply n times n, I get n squared times the cube root of n. And this would be our most simplified answer. So all we have done here is we said, how many groups of 3 can we make? So that's like saying, how many times does 3 go into 7? So it went in 2 times with 1 left over. That's why this ends up as an n to the 1st. So the short way that we could have done this is I like to set it up kind of like a little dividing line. I always start my radical and then I sort things. They either go on the left side or the right side. So I divide first. How many times does 3 go into 7? It goes in twice evenly. So the evenly bits come out. So I get n squared. And when it goes in twice, there is 1 left over. So that's how we get to the simplified form. Let me show you another kind of simple example like that. Let's say that I had the 5th root of a to the 29th. So we look at this and we say, set up our little dividing line here, how many times does 5 go into 29? It would go in 5 times, so a to the 5th comes out, with 4 left over. So a to the 4th stays in, and this would be your simplified answer. Notice that if it went in an even number of times, like the 4th root of a to the 16th, there would be 0 left over. So that means there would be nothing in the radical. You would just have the 4 times that it goes in evenly. All right. So let's work some examples. So the first one, we have the cube root of 64y to the 6th. Like I said, we're going to work base by base. So I'm going to first look at the coefficient, the numeric term. So the first thing I check is if 64 is a perfect cube. And it is. The cube root of 64 is 4. So that means we're just going to get a 4 with nothing left over there. So that one's done. Then we move on to the next base, which is y. How many times does 3 go into 6? It goes in 2 times with nothing left over. So again, we get the 2 times here. And since there's nothing left over, that means this one came out evenly and you have no radical left. Number 2 is a little bit different. Let's look at that. So if we look at number 2, I look first with my first one, which is 64. We're doing a 5th root, so you go to your 5th power column. You want to see the biggest number that goes into 64. Well, 64 is 32 times 2. and the fifth root of 32 is 2, but then that other 2 has to stay inside the radical. So again, I'm going to start this here with my little dividing line. Things that go in evenly come out to the left. Things that are left over stay under the radical. So the fifth root of 32 is 2, with that other 2 left over, so it stays inside. Now we look at A. I'm going to try to do this in different colors here. Now we look at the one that has a base of A. How many times does 5 go into 8? It goes in 1 time with 3 left over. So we're just sorting left and right. Then I look at B to the 14th. 5 goes into 14 twice with 4 left over. And lastly, we look at C, and 5 goes into 5 once with nothing left over. And so this is how this ends up working out. Now, I got a little crowded over here, so I might want to rewrite just for clarity. 2ab squared c times the fifth root of 2a cubed b to the fourth. And even though it's still pretty ugly looking, that is our most simplified answer. Now, a way you can kind of check to see that you're on the right track, none of the exponents that are left inside can be bigger than the index. If they are, that means you didn't take out enough of them. So you would want to simplify some more. So that's the end. All right, let's look at number 3. The first thing I would do is split this apart. Whoops, I'm still on highlighter here. Split this apart into 2 radicals. The fifth root of x to the 10th over the fifth root of y to the 5th. And so now we want to try to simplify that. 5 goes into 10 2 times with nothing left over, so we don't need that radical anymore. Over, now we look at the y's. 5 goes into 5 once, y to the first, again with nothing left over, so this is the most simplified. Lastly, with number 4, I'm going to have you pause this and try this one on your own, but I'm going to give you a hint before you start. It would probably be easier to combine this into one radical before you start simplifying. So I would go ahead and multiply across first. Go ahead and try that and then see if you can simplify and then come on back to me. So when I multiply, we get the cube root of 4 times 12 is 48. X cubed doesn't have a match, so it stays the same. Y to the 5th times y to the 2nd, when we add those exponents, we get y to the 7th. All right, so again, we're going to go one piece at a time. I already know that like 3 doesn't go into 7 evenly, so I know I'm going to have leftovers, so I'm going to set up my dividing line. So I look at 48 and I want to find the biggest perfect cube that goes into 48, and it's 8. 48 is 8 times 6. So the cube root of 8 comes out evenly. That one comes out. And then the 6 doesn't go in evenly, so it stays out here. Then I look at the x's. 3 goes into 3 once with none left over. And I move on to the y's. 3 goes into 7 twice with 1 left over. Double check your exponents here. 6 is not a perfect cube. There's none that go into it. This is a y to the first, so it's not bigger than 3. So that's how you know that you're all set. That's all there is.